This is an interesting one. This is actually a result of a company in Australia. One Steel is a steel mill. We don't have many left in Australia. There's a couple. One of them is the One Steel operation. And what they did was go back and have a look at all their work orders, maintenance work orders, for a period of time. And this is the pie chart that they put together. And what they found was that 48% of their maintenance was repeated every 3 months. In fact, 30% was repeated every month. So every month, the same things broke again and again and again. And after 3 months, half of the maintenance was repetitive maintenance. It got them to investigate why these things are happening. This company's been on a journey now, a reliability improvement journey now, for about 8 years. And in that 8 years, they've learnt a lot about why their plant is a problem for them. What they found is that if we want to have high reliability, there's a particular zone we have to be in. This curve here talks about what is an acceptable degree of perfection and what is unacceptable. What they found is that if we are not in this zone here, this particular area where there is no misalignment, no out of balance, if the vibration is not low, if the design loads are not as designed, if we have water and contamination in our oils, if we have high temperatures in our bearings where the clearances change, if we are this side of that line, where close enough or it's tolerable or it's acceptable, it's not. Once we are this side of that line, the reliability drops to fractions of the design life. It isn't until we cross that boundary and there is no misalignment, there is no out of balance, the total vibration is very low, the design loads are what they should be and where they should be, the oil and lubricant is in very good condition, the temperatures are controlled, so the interference fit of parts are as they should be in that 10 micron zone. Once we cross that boundary and we control the world our parts live in, our reliability jumps up to the full design. It's not a gradual jump, it's a step change. Massive step change. But we have to be in that zone. Nothing else but being in that zone gives us the reliability that we're after. Anything on that side, we never get the uptime, the low costs that are possible with high reliability. High reliability is this zone here.
Is a part of the problem that the company doesn't require the suppliers to meet any better standards. And so the suppliers are just giving them the minimum that they can get away with. And maybe if the company requested better tolerances or better overload, that the suppliers would actually give it to them.
Certainly, if the design is poor to start with, if it's the wrong design, if it's been engineered incorrectly for the situation, then you're going to get poor reliability. So definitely that design choice and the quality of that design and the quality of the build, major factors. Now, if you're a manufacturer and you have no idea that reliability comes from precision, you'll never ask for it. The thing is, once you know you've got to be in the zone and nothing else but that zone will do, you can go and ask for that. Can the supplier deliver it? I don't know. If they could deliver it, they might do it. What bothers me, it says to me that the manufacturer of machines don't understand this themselves. I'm buying machines brand new that are nowhere near this zone to start with. Brand new machines. The manufacturers around the world, few of them, I can't say everybody, but few of them understand this concept. There's only a very small tight zone and it has to be in that zone, and anything else, close enough is not close enough. It's a step change. It's fall off a cliff. It's like falling off a cliff. So in plant wellness, precision maintenance is about, that's the zone of precision. What is that zone? What are these numbers that ensure we're in that zone? Because I know once I'm in that zone, it will be right. Then I'm going to build the process, the business process that always drives us to this zone, because the message is very clear. If I'm in that zone, I will get reliability. I can create reliability intentionally, but I have to know those numbers. And my guys have to understand what those numbers mean, and my suppliers and manufacturers have to understand those numbers as well. So I might have to go back out and educate my suppliers and say, guys, here's the zone we want your machines for you to build to. And anything else less than that, go back to the shop floor and do it properly. So that's part of the solution for sure. That's what I'm saying. We've known these answers now for at least 25 years, yet it's not happening. So this connection between knowledge and practice in the real world, there's a misconnection, and we've got to make that connection as soon as possible, because that's going to make a big difference to all of us.